Next, the next process is isothermal humidification. Isothermal refers to what? Constant temperature. Right, constant temperature. Humidification means adding the moisture. So first of all, we'll discuss how we can add the moisture. So we can add the moisture with the different ways. You see, in this isothermal humidification, we are adding the moisture by using a steam, or we are heating the water by using the heating coil like a heater, and we are making that water, we are adding the heat to the water and will make it evaporate, or else we are providing the steam. We have the process of spraying the water also, that you'll find in adiabatic humidifier. That is the next. Okay, in that we are not adding the heat to the moisture, but in this case, isothermal humidification, you see, we are adding the we are adding the steam, and the steam is generated by using a steamer, or by using this electrical resistance steamer, etc., or by using the heat with the natural gas or electrical energy, or with the boiler, etc. Different types of sources for heat. So that system we'll discuss later. At this level, just I've given the idea to understand this process. So the requirement is what? Isothermal humidification means we are maintaining the same temperature and we are adding the moisture. You see, isothermal humidification, so we are not changing the temperature, because the process will give you the idea, na? At constant temperature, we are adding the moisture. So now you see, our requirement is 75 degree Fahrenheit air from 15 degrees RH. We are interested to maintain this 50% RH. In this, we are not disturbing the temperature, just we are increasing the RH. Okay, as per the process. Getting a point. Temperature is constant, just we are increasing the humidity. And increasing the humidity, the process called humidification, by using a steam, or by introducing a steam. So what are the different conditions you'll get? First of all, you see, this is point 1 and this is point 2. So what are the condition at point 1? At point 1, dry bulb temperature is what? 75 degree Fahrenheit, and RH 15%. Okay. Actually, with this condition only we got this point. You know how to get this point in the psychrometric chart. Now, if you talk about point 2 conditions, you see, this is a desired condition. Dry bulb temperature 75. What? Same, because isothermal, na? Yes. And what about the RH? 50%. 50%. That is desired condition. Yes. And how we can achieve this? Simply by adding the moisture. And moisture means the heated steam. Now, what will happen to this humidity ratio? We'll discuss now. Now we'll talk about this humidity ratio. So W1, you see, this is a point, na? This is 20 grains per pound. And what about W2? Increase or it will increase or decrease? Increase. See? 70. Obviously, we're adding, so increase. Adding the moisture, na? So definitely this humidity ratio means more grains per pound of dry air will increase. Okay, so this is when you check above 60, I'm getting 64.6 grains per pound of dry air. Okay, this can be happen by, you see, we are not increasing the temperature. Then how this humidification process, or how we can achieve this RH? Definitely by adding the heat, na? So now we'll check the enthalpy. H1. You see, this is point 1. So this H1, you see 20, 25. So here I got 22 BTU per pound. Then H2, you see, this is a point. 28. When you check, I'm getting 29 BTU per pound. And therefore, delta H is what? 7. It means by adding this 7 BTU for this pound, one can increase the RH without increasing the temperature. Now the question is, adding the heat, but temperature is not increasing. Then where the heat goes? Yes, exactly. My question is that heat is utilized to change the phase of that water. Change the phase. We are providing the moisture, this steam, na? So to convert that water to steam, heat is required. So we're adding this 7 BTU of heat to the moisture so that it can evaporate and mix in the room so that the RH increases.
Okay.
At same temperature. You see, the RH is increasing because of same temperature. If the temperature decrease or increase, the case will be different. The holding capacity will be different. No? With the same temperature, if you add the moisture, RH also will increase, right? Okay, so this is isothermal humidification process. Just focus on the process. Don't think for overall condition because we are not talking about the system at this level. Just we are talking about only process. And just you need to understand, if you maintain the same temperature and adding the humidity, what will happen to the other parameter? So that at the time of designing, this information will help controlling which parameter to change what parameter as per the requirement. Okay. Because, for example, for a particular process control, we are not interested to increase or decrease the temperature, but we are interested to maintain the moisture level. So this can be done with this process. After class, just you need to go through all this because this is very, very important. Next process is adiabatic humidification process. So adiabatic refers to what?
Energy.
Means, yeah, constant enthalpy. Means no exchange of heat. Means we are not adding or removing the heat, but we are increasing the moisture. That is nothing but adiabatic humidification process. So this can be done. You see, this is 0.1, this is 0.2. 0.1 condition, you see, 80 degree Fahrenheit and 13% RH. You can see 18% and 13% RH. This is the point. I'm interested to increase this humidity level to 50% without adding the heat. In the previous case, we add the heat, na? But in this case, we are interested to increase the RH, but without adding the heat. So how it can be done? I'll show you. So you see 0.1 condition. Anyhow, 0.1 condition you can relate here. Then 0.2 condition, T1. You see, T1 is what? I can consider
65.
Sorry, T2, na? 0.2 means T2 means what?
65.
Yes, 65 degree Fahrenheit. Next, what about this? In this case, you see, enthalpy. I can consider H1 equal to H2 because the line is going parallel to this inclined line. Na? Means it's not increasing the enthalpy because these are the enthalpy points. So it's not increasing, it's same. So H1 equal to H2, which is what? 22.3 BT per hour. Now we'll check this humidity ratio W1, W2. W1 you see 20 grains per pound. What about W2? 45.5 grains per pound. Delta W I can consider 25.5 grains per pound. Okay. Now the question is, without adding the heat, how we are increasing the moisture, right? In the previous case, we add the heat to the water and that water is changing to steam, and the steam we are adding in the space. Means adding the heat at constant temperature, we increase the RH. But in this case, we are not adding the heat, but increasing the moisture. How? This is a simple process. What we are doing, we are allowing the air to pass through a wet medium like a honeycomb or any wet medium. Like a wet filter or a honeycomb, or alternately one can use very narrow jets of water and spraying the water with a means like we are using the spray bottle. So just spraying the water inside the room. with a very what you can say, very small particles. So what will happen? The room air will extract that moisture. Okay. In the previous case, we add the steam, that is a hot moisture, but here there is no hot moisture, the same temperature moisture. Just we are spraying. It means we are not adding the heat. And because of this, you see the temperature is decreasing, na? The room temperature decreasing because that room air heat is extracted by the moisture what we are supplying, like evaporative cooling. Okay, like evaporation. Okay, so in some application you'll find, or we can say air washers, or similar to air cooler. Not exactly. Air cooler we can call evaporative cooling, but in this we are not talking about cooling, just we are talking about this increasing the RH. Got the idea online?
Yes.
And the same theory what I explained is given here. You see with the specialized nozzles or dispensers, we are applying the water inside the space. Okay, so this is adiabatic humidification. In some applications, you'll find this one. Next, we have evaporative cooling and the mixing air. Okay, this we'll discuss in the next session. So what you do, just go through this. We have only two processes, and after that, we have very important equations. Not lengthy, but important. So in next session, within 15 minutes, I'll complete this so that we can start chapter 4, classification of machine. But as I said, still some more topics related to psychrometry, that is contact factor, bypass factor, and the psychrometric analysis that you'll find in load calculation, chapter 7. And all this information, what we are learning here, we'll use in psychrometric analysis also.